Hello class, welcome to Pre-Algebra Lesson 2.6, which is all about using properties of integer exponents. By the end of this lesson, you should be able to use the properties of exponents to write equivalent expressions. And I would like to do just a little disclaimer that Lesson 2.7 is actually going to introduce even more properties with integer exponents. That one's going to focus more on the negative exponents, okay? But for lesson 2.6, we're going to focus on integer exponents, specifically positive exponents. So by the end of this lesson, you should be able to use those properties of exponents to write equivalent expressions. Just a reminder, equivalent means like I could write 3 plus 4 equals 7. Those two different quantities are equivalent, and then 3 plus 4 is an example of an expression, or 7 is an example of an expression. As we're going through this lesson, you'll see me write my answer in different formats based on what the directions say. Sometimes it's going to be asking for you to solve or give an exact number. Other times it's going to ask for an expression, and it's going to end up being something that's not like fully simplified down to a single number, okay? So let's jump into this very first example. We have multiplying exponential expressions that have the same base. So let's do a quick little recap. Actually, I'll read the problem and then do a recap. The weight of a newborn caribou is shown below. The adult caribou weighs about 2 to the 6th times more than the newborn. How can you determine the weight of the adult caribou? Okay, so let's just refresh a couple of things. The newborn, it says over on the picture, weighs 2 to the 3rd pounds. Okay, and if we break that down a little bit, we have 2 and then that little 3 raised up and over to the right. Okay, so that 3, that's an example of an exponent. Okay, and then this larger number at the bottom, that's called the base. Okay, the whole thing put together is called a power, which seems a little confusing because sometimes when we read this, we would say 2 to the power of 3 or 2 to the 3rd power. And that's all just fine, honestly. What I need you to know is that this number right here is the base. Okay, so that big number, that is the base. And let's recall that 2 to the 3rd power, that's the same as saying 2 times 2 times 2, right? It's saying I have the number 2 and I'm multiplying it 3 times. Be careful not to just say 2 to the 3rd power is the same as 2 times 3, because that's false. It is not 2 times 3. Alright, so now that we've recapped a little bit of information, I'm going to go off. I'm just going to put that off to the side with that vocab. So we know that the newborn is 2 to the 3rd pounds, and then we know that the adult caribou weighs 2 to the 6th times more than the newborn. So what I can do is multiply those together to determine the weight of the adult caribou, right? So I would say 2 times 2 times 2. That's going to be this 2 to the 3rd, right? And then I'm going to say times, and then 2 to the 6th is the same as having 6 2's that are all multiplying together. All right, so you can see I have a lot of 2's listed right here. And let's make it easier to read, right? So I see I have 3 2's here, I have 3 more, and I have 3 more. So I can see in total I have 1, 2, 3, 4, 5, 6, 7, 8, 9 2's. So when I write it out, I can see that 2 to the third times 2 to the sixth, that's the same as taking 2 or 9 different 2's and multiplying them all together. And congratulations, you have now reached the part of math class where you'd use a calculator. So let me show you how you would type this into a calculator. So the first thing you're going to do is you're going to hit that 2, and then you're going to look for something called the caret key. It looks just like this. And then once you've punched that into your calculator, you're going to put a 9. And then you get to hit the equals or the enter. Once you do that, it should tell you that 2 to the ninth is 512. So we know that that adult caribou is 512 pounds. All right. I absolutely want you trying to plug that into your calculator right now to make sure that you know how to use your calculator, because it would be a huge bummer to all of a sudden get to use your calculator and then get everything wrong because you don't know how to use it. Okay, so make sure you're testing this out as we go. Okay, so you can see I was able to figure out 2 to the third times 2 to the sixth. That gave me 9 different 2's that were all multiplying together, but I wrote it out in a really obnoxious fashion. I know you guys do not like writing all of that stuff out, and honestly, it's not always going to be practical to write out all of the different numbers, because what if I said, hey, what's 2 to the 25th times 2 to the 30th? Like, you're not going to write out 25 2's and then 30 more. Like, no. So let's talk about what's the faster or more efficient way of doing this. So I had that 2 to the third times 2 to the sixth, right? Do you guys see how my base appeared 2 times? So if I take out my little highlighter here, I had the base here, the base here. Whenever that base repeats, you can write the base again, and then you take those exponents and you add them together. Okay, so when the base appears more than one time, it's the same base and it appears more than one time, all you have to do is add those exponents together. So I know that I would have 2 to the 3 plus 6 is 9. And then from there, you would just plug it into your calculator to get that 512 pounds. All right, so I showed you one way, and then I showed you a more efficient way. If you need to start with like that orange stuff that I have at the top, go for it by all means. But I do want you working towards that very last, that very bottom step I have on the screen. Okay, now it is your turn. We have the local zoo welcomed a newborn African elephant that weighed 3 to the 4th kilograms. It is expected that at adulthood, the newborn elephant will weigh approximately 3 to the 4th times as much as its birth weight. What expression represents the expected adult weight of the newborn elephant? Okay, so excuse me, you have everything you need. The only thing I want to point out is this one's a little different. It's not asking for the exact weight, it's asking for the expression. So if we were to go back to that last problem, the expression would be leaving it like this at 2 to the ninth, okay? So like on the last one, this would have been our answer. We would have said 2 to the ninth pounds. Okay, so that's how I want you to format your answer for this problem, but use the information about the elephants. Good luck. Okay, for this problem, hopefully you said 3 to the 4th times 3 to the 4th. Well, my base appeared twice, so I just write that base, and then 4 plus 4 is 8. So that's how I got 3 to the 8th kilograms. If you have questions about that, please be sure to reach out for some help. I'm happy to help you. Now, let's look at a really similar but slightly different example. Now we're going to do multiplying exponential expressions, but this time with a different base. Okay, so we want to find the volume in cubic inches of a cube with edge length of 2 feet. So let's just start by looking at some important information here. Okay, so we're looking for volume, right, in cubic inches, but notice that if I keep reading, instead of being labeled as inches, it's being labeled as feet. Okay, so that tells me that I'm going to have to do a little bit of a conversion somewhere. So what I'm going to do is I'm going to start with what would the volume be of a cube with the length 2 feet? So volume, remember, is the side cubed. Okay, so the volume is going to be 2 cubed. All right, then if we were to switch over to the inches, well, what would the side length of inches be? The side length for inches would just be 12 inches if we were talking about like just 1 cubic foot, right? Okay, so we have 12 to the third power would be the volume for a 1 cubic foot cube. Okay, so I have 2 to the third times 12 to the third. Okay, so what this is doing is this is taking the volume of the entire cube, but then splitting it up into all of those little inch pieces, right? Okay, so the volume of the cube, and then the 12 cubed represents splitting it up into the inches instead. Okay, so I'm going to go back just a little bit here. You can see this is, excuse me, the expression. So if I were to break it down, it would be 2 times 2 times 2 times 12 times 12 times 12. Now if I look at that, I see a lot of repeats, right? Like there's a 2, and then there's a 12, there's another 2, and another 12, and there's a third pair, right? Now you might be wondering, why on earth am I doing this? That's a valid question because I haven't really explained. I'm just observing some patterns. However, since I know the end goal of what I want you to know, it makes it a little bit easier for me to observe that pattern. So if what I just did seems like, how on earth would I pick up on that on my own? Don't worry about it. It's okay. That's what I'm here to show you, okay? So I saw that I have pairs, and the reason that's important is because then what you can do is say I have 3 and then pairs of 2 times 12 essentially, right? Like that's an even faster way to write this problem. And then with that, if you remember your order of operations, you always simplify inside those parentheses. So 2 times 12 would be 24 to the third power. And now I no longer need those parentheses because it's down to just a single digit. So I would have 24 cubed as my volume in cubic inches. And I know that can look a little confusing once you have a label, but we're not quite done because I want to know what is that number. So again, I'm going to type in 2, 4, caret 3, and then the equals. And when I do that, I get 13,824 cubic inches as my final answer. Okay, so that would be my final answer for this problem, but let's go back and just recap quickly. Okay, so I was finding the volume in cubic inches from something that had a length in feet. So I started by figuring out what's the volume in feet, and since I know that feet is the bigger unit, right? I know that my number is only going to get bigger because I'm taking this cube and I'm splitting it up into all of these little pieces down here, right? So my answer is going to become a larger number. So I'm multiplying by, and then I knew that I was splitting it into 12 pieces on each side. So I have 2 to the third times 12 to the third. And then when I did that, I noticed that I had pairs, right? For every 2, there was a 12. And then a faster way of writing that would just be to write it in parentheses. So what you're going to do is you always take your base numbers and multiply them together, and then put the exponent that is the common exponent, essentially. See how these both had a 3? I put that common exponent on the outside of those parentheses, and then you simplify inside and write it with that common exponent. And then if it asks for an actual number, you solve it. If it asks for an expression, you would stop with 24 cubed. All right. Hopefully that makes sense. If not, it's okay. Ask questions. I'm here to help. Let's look at another rule. This one's called the power of a power. And what this means is you can see I have 5 to the second to the fourth. Do you guys see how these two exponents are basically right next to each other? There's not another base. There's only that one base and then 2 exponents. Okay, so whenever that happens, what I'm about to show you is what you're going to do. Alright, so I have 5 to the second inside those parentheses, right? And then see how that 4 is outside? That tells me I have 4 sets of these parentheses. So it would look something like this. Alright, and then another way of writing it without parentheses would honestly be just to rewrite it with multiplication symbols in between. And when we do that, hopefully you see that this looks very similar to what we did on that very first problem, where when we have the same base, in this case 5, you take your exponents and you add them together. So I would have 5 to the 8th. That would be my equivalent expression. Now, that's the visual way. Now let me show you the shortcut way that as you get more comfortable, this is what you do. So what you do is you take that base, you write the inside exponent, and then you just say times the outside exponent. So 5 raised to the 2 times 4 is 8. So you can see I end up at the same exact answer, but with a slightly different way to get there. If you have questions about that, please reach out for some help. I also don't think I've mentioned, make sure you're writing some of these down, because if you're not, this assignment's going to be really tough. Okay, you want to make sure you're taking good notes on this. All right, then let's look at this one. Divide exponential expressions that have the same base. Okay, so we have 6 to the 5th divided by 6 to the 3rd. So here's a friendly reminder that when you see division, another way that we can write that division is using a fraction. And that's going to make your life really a lot easier to visualize what's happening. So 6 to the 5th, that means that I have 5 6's on top of my fraction. And the reason I know that it's on top is because the top is always listed first and the bottom is always listed second. Okay. Then on the bottom I have 6 to the 3rd, so that means I have 3 6's on the bottom. Alright, this is where things get a little fun. When you have something that repeats with multiplication on top and bottom, you get to cross it off. So you can see I have a 6 on top, 6 on bottom, 6 on top, 6 on bottom, 6 on top, 6 on bottom. And then I don't have anything else left on the bottom, so I know I can't simplify anything else. But what I do know from that is that I'm left with 6 times 6 on the top, and then the bottom would become a 1. If you're wondering why that is, let me give you a quick little example. So we had practiced a while back multiplying fractions, and some of you had practiced reducing on the diagonals or top and bottom before multiplying. So I would say, okay, 3 can go into itself 1 time, and it can go into 9 3 times. So just like you would put that placeholder 1 above the top 3 there, you're going to put a 1 on the bottom. When everything goes away, you put a placeholder 1 there. Okay, and then 6 times 6 is just 36. So I know that my final answer would be 36, except since it's asking for an equivalent expression, what I would do instead is I would say that was 2 6s, or 6 to the second power. Okay, so that's one way to solve this. Now the faster way, I have 6 to the 5th divided by 6 to the 3rd. You will often see it written as fractions, and what you do is you take your top exponent and you subtract your bottom. So 6 raised to the 5 minus 3 would be not 3, I'm tired, 2. So 6 to the second. Alright, if you have questions about that, ask for help, please, please, please. Alright, this next example, it's going to have, the next slide's going to have 4 problems on it, and I'm going to go through them one at a time, okay? Alright, so why don't you go ahead and try letter A on your own. Notice the directions say to write equivalent expressions, and that's going to be for all 4 problems, okay? So you're not telling me the exact number, you're giving me the expression. Good luck. Alright, for this problem, hopefully you said it was 7 to the 6th power because you recognize this was a power to a power. There's no base in between those, so we multiply. Alright, now next one, we have 4 to the 5th times 4 to the 3rd. Good luck. Okay, for this problem, hopefully you saw the base repeated, right? That 4 appeared 2 times, so I knew I just needed to add my exponents together. So 5 plus 3 is 8. So my answer would be 4 to the 8th power. Be careful when you are doing these problems. Sometimes I see students rush, and this is the answer they would circle. That is not correct, okay? If you were to test it out, 4 to the 8th, if you actually cared to type that into a calculator, you would get 65,536. So if you write down 8 and you try to convince me that it's the same thing, I'm not going to be convinced. I could maybe be convinced into half credit because you clearly knew that you needed to add your exponents together, but you cannot forget your base, okay? So make sure you write down your base again. Let's look at letter C. We have 9 to the 4th times 8 to the 4th. Go ahead and solve this one. Good luck. Alright, for this problem, hopefully you recognized that they have the same exponent but different bases, so I can group those bases together in parentheses. And I would get 9 times 8 raised to the 4th power. 9 times 8 is 72, so my answer is going to be 72 to the 4th power. Alright, the last problem for today is 8 to the 9th divided by 8 to the 3rd. Good luck. Alright, for this one, hopefully you ended up with 8 to the 6th power, but if not, please be sure to double check your work. Make sure you subtracted your exponents. Actually, when I made my notes earlier, I was rushing, so you know what I did? I said 9 minus 3 was 3 because my brain saw this division sign. So be better than me. Just make sure you slow down, take your time. Okay, so 9 minus 3 is going to be 6. If you have questions, reach out for help. I'm happy to help you. But on this last slide here, you will just see kind of the 4 different rules that you learned about. I did not always name them because sometimes giving you guys the names overwhelms you, especially when it's something new. So I just want to kind of show you. We have the product of powers property, and then you guys went on and you learned another version of power of products property. That's when the bases are different. And then you also learned about the power of a power or power to a power property. And the last one we finished up with today was the quotient of powers property. Okay, so please be sure to make sure that you have at least an example for each of those written down. And sometimes students find it really helpful to make little flashcards with those properties just to study for the test, okay? Or even use on your assignment and then use them to study for your test. So do with that information what you will, but that is everything. I hope you guys have a great day.